Hi everyone, it's Coach Fred here, and today we're going to be talking about solving a linear system of equations by graphing. Um, and let's just clarify and make sure we understand what a system of equations is. So a set of equations that have a common solution we refer to as a system of equations. So anytime equations have a common solution, we would call them a system of equations. Now, specifically, we're going to be looking at linear systems of equations. So that means that this set of equations are linear equations. So here's an example of a system of linear equations. First, I want you to notice they're all lines because the highest exponent of x is a 1. And there's two of them. So we have two lines. And when they're provided to you like this, we say that it's a system of equations. Now, we're looking for their solution. Well, if they relate to each other, a solution to a system of two equations is a point, an x comma y, a point that makes both equations true. That's the mathy way of saying the solution to a system. But I want you to think about that graphically. Graphically, that means it's where the two lines intersect. So where the two lines intersect. So I took the liberty of graphing this system in Desmos. And the first line is the red line. So that we would call x plus 2y equals 7. And this one is x equals y plus 4, okay? And when they were graphed, you can see that their point of intersection was right here. So that's the coordinate point 5, 1. So the solution to when I solve this system by graphing, their point of intersection is 5, 1. Now, some of you already know how to solve it algebraically, but right now we're going to look at it graphically. So how do we do that? How do we solve a system by graphing? Well, we graph. But, whoa, Coach Fred almost forgot. There's two things that can happen. In this answer, we got a point of intersection. The lines intersected. But what if the lines never intersect? It doesn't mean that you can't graph them. It just means that the lines are parallel. So that's true. They would not have a solution to the system, but it means the lines would be parallel. And then in the last unit, you learned that parallel lines then have the same slope. So if I see two line equations that have the same slope, I know immediately that they're never going to intersect. So I know immediately the system's not going to have a solution. All right, but then there's one other thing that can happen. These lines can always intersect. It actually means that the lines are the same line. And we would say that it has infinite solutions. And if you want to get even mathier, we would say that the lines coincide. Okay, we call them coincidental lines. All right, well, let's talk about how we're going to graph. Most of the time we're going to be using Desmos, but we want to be able to do this by hand. So when I look at graphing, I'm going to graph one of two ways. I can either put them in y equals mx plus b. So I could, number one, I could move to y equals mx plus b. Or I could graph using the intercepts. Now, I tend to do this if they're in standard form. So if they're in the form ax plus by equals c, that's called standard form, I tend to do that, but whatever you feel the most comfortable with. So I'm going to actually do it both ways. The first one is in standard form, ax plus by equals c. So I'm going to actually use the intercepts in this one. So I'm going to do it over here. So x minus y equals 3. When I use the intercepts, I like to make a quick table for myself. And the intercepts are where the x's and the y's are zeros. So to find the y-intercept, I let x be 0. If x is 0, so we get 0 minus y equals 3. Then y is going to equal negative 3. Okay? All right. And if y is 0, I actually call this the cover-up method. I can just cover up y, so then x would be 3. So those are my points. I'm going to graph them in blue on my graph. So I've got 3, 0 on the x-axis and negative 3, 0 on the y-axis. I'm going to try and use a ruler if I can. And I'm going to always make sure that I go off the graph, and I'm going to put arrows at the end. And I'm going to label that x minus y equals 3. All right, now the other line, I'm actually going to put in y equals mx plus b because I want to show you both ways. So I'm going to do this one in red. So to do that, I would have to subtract 2x to the other side. So I get y equals negative 2x plus 3. My slope is negative 2, and my y-intercept is 0, 3. All right, so I'm going to start by plotting my y-intercept of 0, 3, which is 1, 2, 3. And I'm going to use my slope of negative 2. So that means down 2, left 1. So I'm going to go down 2 and to the left 1 and plot a point. I'm going to do it again. Down 2 and to the left 1, and I'm going to plot a point. And then I'm going to draw my line. I'm actually going to change the color in a second because I want it to be red. Try to get it through all my points. Okay, and let's change the color to red. There we go. And I'm going to label it y equals negative 2x plus 3. Okay, so I drew the lines, but what I'm really looking for is that point of intersection, which appears to be 2, negative 1. Okay, now I'm going to always let you check your answer on Desmos because when we graph by hand, it can get really touchy. I'm going to go to Desmos. And I'm going to put in my graphs. Sorry about that, guys. I'm going to start graphing. I just typed in Desmos. And I'm going to start graphing. And I've got the first one, which is x minus y equals 3. X minus y equals 3. Is that my graph? Yep, that's my graph. And my other one was y equals negative 2x plus 3. So I'm going to do my second one, y equals negative 2x plus 3. And I'm going to look at the point of intersection, 2, negative 1. And I'm right, so I've checked my work. Okay? All right, so I want you to try one right now. I want you to try y plus 2x equals 5 and negative 5x plus 2y equals 10. And then I want you to check your answer on Desmos. If you got it wrong, let me know, and I'll see what I can do to help you, okay? All right, but we're going to move on in this video. So you're going to press pause, go ahead and try that, and then come check it on Desmos. All right, so we got to talk about those other two situations. So let's look at these. We've got to talk about what happens if the lines are parallel or they are the same line. So let's look at what happens here. So 2x minus y equals 1 and 6x minus 3y equals 12. To be honest with you, I'm going to probably put the first one into slope-intercept form. So I'm going to bring the y to the other side, and I'm going to subtract the 1. So that's going to give me y equals 2x minus 1. All right, I'm going to do the same thing with the other one because I want you to see what happens. So I'm going to subtract 6x to the other side. So I have negative 3y equals negative 6x plus 12. And then I'm going to divide everything by negative 3. And that's going to give me y equals 2x minus 4. So right away, I notice that the slopes are exactly the same. So I'm going to be really careful. That means that these lines are parallel. It means they do not have a point of intersection. I'm going to plot them though, and I'm going to draw them. So I have, here's my 2x minus 1. There's my negative 1. Here, I'll do that one in red. And I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to draw a line. I'm going to do my best to draw my line. And then I'm going to label my line carefully, y equals 2x minus 1. All right, my other one, I'm going to go down to -4. So 1, 2, 3, 4. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to draw that line. And again, it's kind of, you have to be really, really careful. And then I'm going to label that line y equals 2x minus 4. And you can see carefully they have no point of intersection, so my answer to the system would be no solution. Okay? All right, guys, we're going to look at the last case in class tomorrow, but I hope that was clear. And again, we're going to do the last case and we're going to do another practice problem, and then we're going to recap it all, and then I might have you try a few to practice, okay? But again, you can always check your answers on Desmos, so have a great day.